record these sessions and I will make it available to you so that you don't have to take notes if you don't want.
Sure. But
while we're doing it, it actually sometimes is better if you don't. I'd rather your attention be on solving the problem rather than taking notes.
okay.
So what's the question about this function?
The question is, let's see. The question is, find basically to simplify it and kind
solve
of
it?
Yeah, just solve it.
Okay. So if we're solving a quadratic, the best thing to do is to set it equal to 0.
Right.
All right, so let's do that. And then we have two choices. The reason we set it equal to 0 is because we still can't solve this. Right. But if I can factor it into the product of two things that's equal to 0, then I can solve it, because then I can set each of those two things equal to 0. Okay? Yep. So if I'm going to factor this expression, it's never very convenient to have a negative sign in front of your coefficient of the x squared term. So let's get rid of that. How can I get rid of that negative in front of the 4?
I heard using a parentheses might help.
Well, let's divide everything by -1.
-1?
Yeah, with algebra, you can do anything you want to the left side of the equation, as long as you do it to the right.
Right.
So I'm going to divide that whole thing by -1.
Okay.
And the nice thing about that is 0 divided by -1 is still 0. So that turns this into a positive 4x squared plus 5x minus 2 equals 0. And this is almost by definition easier to solve because we don't have a negative coefficient in front of x squared. It's still not that easy to solve. Let's see if we can factor it. These problems where you have a coefficient other than 1 in front of the x squared term require a little bit of trial and error. So the first step in factoring is always to split up the x squared terms.
Right.
So what's a good way to split up 4x squared? What two terms multiplied together would equal 4x squared?
Got me thinking there. Let's see. So we got two terms that multiply into 4x squared. Well, there's really a couple ways of looking at it.
Yes, there is.
So
and you want an x in each of them. In other words, I don't want 4x squared times 1.
Right.
So I want some number of x there and some number of x here. And what I usually suggest is just try it with the factors that are closest together.
Right. So
2x times 2x would give you that 4x squared. Okay. And what do the signs have to be? The same or opposite? That's kind of the next step.
Like opposite.
Yeah, they have to be either. And as long as I have the same coefficient in front of the x, then plus minus is the same as minus plus. So I don't have to consider the minus plus different. I would if this was like a 2x times a 3x. Then I would have to consider both situations. So the next step is, what are factors of 2?
Oh, just 2 and 1.
Yeah, and there's only two choices here. Either the 2 can go there and the 1 can go there, or vice versa. Right. And let's figure out if this combination produces the middle term. That's always the key. You get the middle term from the inside and the outside. Well, I can see that that's plus 4x minus 2x. That does not produce 5x. So that is definitely not correct. Let's switch them. That's not correct either, because that produces a 2x in the middle and a minus 4x on the outside. So therefore, let's go back and split up the x and try 4 and 1. And I'm still constrained by the factors have to be equal to minus 2. So it still is either plus 1 and minus 2 or plus 2 and minus 1. And this also does not produce 5x. So let's try the last possible combination. And that also does not produce 5x.
So it wouldn't be a solution.
Well, there is a solution, but it's not obtainable from factoring. So we can discard this method.
All right.
Some quadratics can be factored, others cannot. And when you find one that can't be factored, there always is a solution. It's just that you have to use the quadratic formula.
Oh, wait, right.
Okay, and the quadratic formula says what? Do you have it memorized?
No, I have that memorized. It's x equals negative b plus minus the square root of b squared over 4ac all over 2a.
B squared minus 4ac all over 2a.
Mm-hmm.
And in this case, what's a?
A is 4.
What's b?
5.
And what's
C is negative 2.
Okay, so if we substitute, we get x equals minus 5 plus 4 minus square root of 25 minus, and I always recommend doing it like this because there's frequently a problem with signs. You don't want to get the sign wrong. You with me?
I'm with you.
Okay, let's erase this so I have room to write and condense this. So we got x equals minus 5 plus or minus. And the way I usually do this is to calculate that, which is minus 32. So I have a 25 minus a minus 32. With me?
Yep.
That is 57, positive 57. Still all over 8. And now the only question is, can you reduce the radical? Can you simplify it?
No.
And in order to be able to simplify it, you have to be able to find a factor that is a perfect square number. And you don't have that many perfect square numbers. You have 4, you have 9, you have 16, you have 25. If none of those can divide into 57, then it's simplified. 4 can't, 9 cannot, 16 cannot, and 25 cannot. So that is my final answer. And it does, what this means, in case you're not aware, is one of the answers is x equals minus 5 plus root 57 over 8. And the other answer is x equals minus 5 minus root 57 over 8. And I can't simplify any part of that.
Right.
If I was able to pull out a number that went with 5 and 8, then I might be able to simplify the whole thing down. But in this case, I cannot. So this presents the ultimate question, which is, how do you know whether you can factor that or you're going to have to use the quadratic form? And the answer is you don't really. There's no way to really know, at least not that I know of. And so I always spend a few minutes trying to factor it normal way until I give up and realize that it can't be factored normally, and I'm going to end up with the roots being irrational. The final, whenever you have to use the quadratic formula, you generally end up with irrational roots, meaning there's going to be a radical sign somewhere. Because every number that's in a radical is irrational if it can't be turned into a rational number. Like the square root of 16 would be 4. So that would not be an irrational answer. But square root of 57 is irrational, and there's no way to reduce it any further. So I guess what I would suggest is, if you're taking a test, especially if it's being timed, if you're really good with the quadratic formula, it might be worth jumping straight to that rather than spending 5 minutes trying to factor it.
All right.
And that's kind of your call. If you know you're dealing with a problem that's not going to be factorable, in other words, it's a section where they expect you to use the quadratic formula, then you can be pretty sure that that's not going to factor nicely. And go ahead and jump straight into the quadratic formula. It's not that tough, especially if you remember what it is. And you can get to the answer. Now, if that was factorable, then you would get an answer. Even using the quadratic formula, you would still get the correct answer. You would just get x equals minus 5 plus or minus 3, something like that. So you would still get whole numbers as your answers for x. They wouldn't be irrational. And if you get rational answers using the quadratic formula, is all that means is that you could have factored.
Okay.
But the quadratic formula will always give you the correct answer, even if it was factorable. And another thing, that if I'm going to use the quadratic formula, I don't need to do that step there. Just go ahead and make A equal to minus 4, B equal to minus 5, and C equal to plus 2. It will produce the same result. You with me?
Yep.
Okay. The only reason I divided everything by minus 1 was because it gave me an opportunity to deal with a regular looking quadratic and gave me a chance to see whether I could factor it or not. And I tried all possible combinations, didn't factor nicely, so I went to the quadratic formula.
All right.
And that's pretty much the methodology you need to use. If you're, if the problem says use the quadratic formula to solve this, then go straight into the quadratic formula. Don't even attempt to factor it.
All right. Yeah, kind of the funny thing is, I think some of the stuff I do kind of, remember, back in like high school algebra or something.
Yeah, in algebra 2, towards the end of it, you would have had to try to factor quadratics that the biggest difference in quadratics is whether it has that coefficient of 1 or something else. And if it's something else, that makes it a lot tougher.
Oh, yeah. Anyway, what really got to me was, I think, with square roots or something. I'm not the best at square roots, so I'll read another problem to you.
Okay.
F of x equals the square root of x minus 2.
All of it under the radical or the minus 2?
just the square root of x. X is under the radical only. -2.
Okay. And they're asking you to solve for the zeros of this function?
Yeah.
Okay, whenever they ask you to solve for the zeros, you can set the whole thing equal to 0. Like that. Now, we want to end up with x equals something. So I've got to eliminate everything that is not x. And it's usually correct to start with any numbers that are being added or subtracted. Get rid of that -2. How do you do that?
We add that and put it on the other side. So we just have square root of x on one side and 2 on the other side.
Now how do I get rid of the radical sign?
This part
You square it.
Square it?
Yeah. Oh. If you're trying to get rid of a square, you square root it. If you're trying to get rid of a square root, you square it. You pretty much always do the opposite. Notice the way we got rid of the -2 was to add 2.
I see.
If we had a multiplier, I would be dividing. If we had a divider, I would be multiplying. So solving equations is all about getting rid of everything that is not x. And another way to look at this, if you want, is I can write x, the square root of x, as x to the 1/2, correct?
Okay.
So that's the same thing. Now, if I want to turn that into x, I square it.
Then that cancels.
Well, the 2 times the 1/2 becomes x to the 1, which becomes x, equals 4.
Let's see.
And if you look and check whether that is true, you have the square root of 4 minus 2 equals 0. Yes, indeed, x is 4. Only plus 4. And by that, I mean, if I actually had this equation, and I'm trying to solve this, then what do I want to do? I want to take the square root of both sides, right?
Mm-hmm.
Well, that turns the left side into x. It's the square root of 25.
Square 5.
So actually plus or minus.
Plus or minus.
And this is a key part that all students miss. And by all, I mean 95% of students omit the plus or minus sign. And the only thing I can say that might help you is that whenever you are solving an equation by taking the square root of both sides, which is what I did here, always 100% of the time begin your answer with the words plus or minus. Because both of these are valid. Notice that x can be minus 5. X squared would be 25. And x can be plus 5. X squared would still be 25. So both of these are equally valid. Now, if you're solving a geometry problem or you're solving a dimension, then dimensions can never be negative and you discard the negative. If you're solving a time problem where you're trying to figure out something is moving on a parabola shape, you're trying to figure out when it hits the ground, well, time can never be negative, so you discard the negative. But if you don't know any of those in advance, then you always, in other words, if you're taking a test and this is the problem, trust me, the answer is x equals plus 4 minus 5.
With you.
Okay.
All right, one more problem. Let's see what else there is. Oh yeah, there's the, oh, here's another good one. Okay. S of x equals, what was it? the absolute value of x plus 3.
Okay.
Well, absolute values I haven't really worked with much.
All right.
So
they're actually pretty easy. Let's talk about it. What's the absolute value of 7? 7.
Just 7.
What's the absolute value of negative 7?
Negative 7.
7. In other words, what absolute value means is it's the size of the number, not the sign, that matters.
Okay.
So the absolute value of minus 13, whoops, excuse me, is 13. The absolute value of, let's leave it at that for the moment, but that's what absolute value means. Now, if I'm trying to solve for the 0 here, then I set that equal to 0, just like the others. Okay?
Mm-hmm.
And when you say that the absolute value of x plus 3 equals some number, it doesn't matter if it's 0 or not, then I can write two statements. Either x plus 3 is equal to 0. In other words, you just write what you wrote and leave the absolute value markers off. Or x plus 3, whatever's inside the absolute value, is equal to negative 0. And both of those create only one answer. X has to be minus 3. But let's make the problem just a little bit tougher. Let's say that's a 2. Okay? And I want you to solve this. Well, then I would be able to say that x plus 3 equals 2 or x plus 3 equals minus 2. Both of those things can be true. And what that would give you would be actually two different solutions. Either x is minus 1 or x is minus 5.
Okay.
And I write them horizontally because whenever you're dealing with absolute value, you're always dealing with two different equations that you're going to then solve vertically. And we're used to solving equations vertically. So when you're dealing with absolute values, it's kind of nice to write the first two equations, that one and that one, horizontal, and then solve each one vertically. And you can tell if you plug that back in, x plus 3 would be the absolute value of minus 2, or plus 2, excuse me, which is equal to 2. Or this one over here, where you have the absolute value. If you plug in that, then you get the absolute value of minus 2, which is also equal to 2. So both that solution and that solution work. And it's generally a good idea to check your work, especially when you're dealing with quadratics, absolute value. There's a lot of functions where you will get two answers and one of them is not possible. Logarithmic, logs frequently have that happen. So just because I come up with two answers doesn't mean both of them are valid. And when I solved that, I got x equals plus or minus 2, or no, excuse me. I got x equal minus 1 or minus 5.
Mm-hmm.
Doesn't mean both of those have to be correct. One of them could be what they call extraneous. And you tend to run into extraneous whenever these three things, square roots, absolute value, and logs. If you have any of these three things, you most likely are going to have one of your two solutions not be valid, because all of these things limit what the answer can be. In other words, if I come up with a plus or minus 2, well, there's no way to take the square root of a negative. So that can't be right. And frequently it'll fail the check test with absolute values. Also with logs, this has to be a positive number, must be positive. So if one of your answers is negative and you're taking the log of it, that solution you throw out.
All right. Makes sense.
Okay. Got time for probably another one here?
Yeah. We have time for another one? I mean,
yeah, sure.
Sure. Great, my thing closed down. Well, that's unfortunate. All right. Now I know a good one. Well, if we have time.
Sure. I got time in that I do not have another appointment at 2:30 today. Sometimes I might, but today I do not. So I can go past.
Yeah, I'm sorry I didn't hear that last part.
I said some days I might not be able to go beyond the scheduled time. Like if I were to have another session at 2:30 today, I would have to go. But I don't have one today, so I'm happy to stay with you and cover another problem if you like.
Sure, great. Oh yeah, here's a good one.
Okay.
I think some of the other problems. I think this is more of a, I guess, transformation graph, but let me read it out. Okay. So f of x equals 1 over x. And then this is also kind of a word problem, so I'll read that part also. And compress horizontally by a factor of 2, translate left 3 units.
Okay. When you're dealing with translations, it actually is quite a broad topic. So we might not actually have time to cover it. This is usually a half-hour session all on its own. Because you have 3 ways to change something horizontally, and you have 3 ways to change something vertically.
All right.
So that's 6 different ways. To compress something, I can go over this problem, but sure. I don't know that I will cover the subject adequately.
Sure. So we could just go over the problem and I guess cover the graph another time.
To compress something horizontally, you want to multiply in the inside of the function. So basically, if I want to compress it by a factor of 2, I want that. So what is that? That's 1 over 2x, right?
Correct.
And if I want to move it 3 units left or right, if it was up or down, it would be a plus or minus outside the function. In other words, if you'd have said 3 units up vertically, I would have done this. Because you said it was a horizontal, then it goes with the function. So the answer is going to be this. And because it's going to the left, it's a and what that is going to do is if I draw my original function, it's a hyperbola like that. And I'm going to compress it. And it doesn't matter in this particular case which one you do first. They're both going to result in the same answer. If there is any kind of reflections, 2 of the 6 translations are reflections, either about the x-axis or about the y-axis. And if there are reflections involved, you have to do those first. Okay. In this case, there are no reflections involved. So I could actually move everything to the left horizontally. So let's draw a new set of axes that are 3 units to the left. So if I were to just move it 3 units to the left, that is 1 over x plus 3. And excuse me, I got it going the wrong direction. And this should be x minus 3. And how did I figure that out? Well, I looked at the picture I had drawn and realized that x when x is 0, I should be at 1/3. Actually, I am. I did it just fine. I didn't do it backwards. That is x plus 3. Because if I want that when x is 0 to be 1/3. That looks like 1/3. Whereas if I'd have moved it the other direction, I'm not sure I'd be able to tell. Yeah, if x was 0, it would be negative. Okay, so if you forget which direction to move it when you're moving it left or right, you can always tell by the resultant graph you get. In other words, if I used a different color, let's say green, and decided, well, I need to go to the right, not the left. Now my graph looks like this. And I can tell that when x is 0, right there, I better have a negative number, and I don't. I have a positive number. So that tells me I moved it the wrong direction. All right. And as I said, this is not an easy subject to cover in 5 minutes. There really are 6 different translations you can do, and you need to know how to do all 6. 3 of them are horizontal, 3 of them are vertical.
All right. Well, I guess in the future, you know, we could go over how to.
Yeah, we can definitely go over those. And you can pretty much take any of your common 10 types of functions and translate them into other functions. Or you can say that pretty much any function can be described as a translation of one of your elementary functions. Your elementary functions being y equal x, y equal x squared, y equal sine x, y equals square root of x, y equal x cubed, y equal x to the third, those kind of elementary functions.
Right.
And most any function you run into is going to be a translation of one of those elementary functions. So the only thing you really need to figure out is how each of these 6 translations works, what it does to the elementary function. And you can figure that out. I'm good with that. I can definitely teach you how to do it. I just can't do it in 5.
Right. I think that's something that's better off being covered.
Let's do that in a future session.
Well, thank you again for your help.
I think I can cover it in a way where you'll understand it 100%.
Sure. Well, anyway, thanks again for taking the time out, and you've been, a great help. And I guess a little bit about myself is that the degree I'm pursuing is kind of a hybrid of science and a bit of a technology, geospatial technology. It's kind of a combination of GIS and geography.
Okay.
And it's very technical. So
yeah. Which means, you're not gonna have to take calculus, if I remember right?
It's not required for this degree, so pre-calc.
Which actually surprises me. You don't run into very many people taking pre-calc that aren't planning on taking calc. It's not really that there's not really any relationship between the two. It's just that in order to do calc, you have to cover all of the subjects that you're covering in pre-calc. Right. You would not be able to do calc without pre-calc, even though pre-calc covers all kinds of subjects that have nothing to do with calculus.
Yeah. Well, anyway, I'm gonna sign off and thank you again.
Okay.
And, look
You're
forward
welcome,
to working
Carl.
with you.
Nice to meet you, and nice hopefully we'll work together again.
Sure thing. All right. Bye.
Okay. Bye-bye.